All right, problem number 5. Margaret is taking 7 preschoolers to the park. How many ways can the children line up single file if Abby, Amy, and Alyssa insist on standing next to each other? All right, so we have 7 kids. We want to line them up. We can mark their positions. 1, 2, 3, 4, 5, 6, 7. Now, if there were no restrictions, we would have 7 choices for the first person in line. And then once that person is in line, then we have 6 more kids left over. And so we have 6 choices for the second person in line, and then 5 and 4 and 3 and 2 and 1. It would be 7 factorial. But we have a restriction here. Abby, Amy, and Alyssa, they want to stand together no matter what. Okay? So, we have to treat this a little bit differently. And my hint to you would be to treat Abby, Amy, and Alyssa as one person, at least initially. Okay, so Abby, Amy, and Alyssa, we could call them the A team, all right? So instead of having 7 places in line, we would have 7 minus 3, 4, plus 1 more place for the A team, right? So we could treat 3 of these positions. So let's redraw them. So essentially we have 5 places in line, but they're going to be filled by one of the 4 preschoolers who aren't in the A team, and then the A team, okay? So we could think about arranging them that way. So we'd have 5 choices for the first one, and those 5 choices would be either the A team or the other 4 preschoolers. And then 4 choices for the second, 3 choices for the third, 2 choices for the fourth, and then finally just 1 person left over who will automatically go in that slot. Okay? So that would be my hint to you, is to try to think of it in terms of, try to think of this Abby, Amy, and Alyssa group as one entity. You know, you can call it the A team. All right, so let's do that. If we do that, we'd have, like I was saying, 5 choices for this position, 4 choices for this position, 3 for this one, 2 for this one, and 1 for this one. So we essentially would get 5 factorial ways of arranging those 5 entities. You know, 4 of the entities are individual children, and one of the entities is the A team. Okay, so you know this position might be the A team. So there might be, you know, actually 3 kids in this position, but we're just treating the A team as one entity, at least initially. Okay, so if we do that, we get 5 factorial ways of arranging, which is 5 times 4 times 3 times 2 times 1, and that's equal to 120 ways. So is that our answer? Well, we have to be careful because this group here, Abby, Amy, and Alyssa, we have to think about how they could be arranged. Okay, we have 3 kids, and we've arranged them within the whole group, but they have their own way of arranging themselves. And how many ways can we arrange Abby, Amy, and Alyssa? Well, we'd have 3 choices for the first one in their grouping, 2 choices for the second, and 1 choice for the third. Okay, so that gives us 6 choices for ways to arrange just Abby, Amy, and Alyssa. So if we have 120 ways of arranging 4 kids and the A team, and then 6 ways of arranging the A team, that gives us 120 times 6, which is equal to 720 ways of arranging all 7 kids, with the restriction that Abby, Amy, and Alyssa have to stand together. Okay? They don't have to stand together in any particular order, but they have to stand together. Okay? And there's 6 ways that they can arrange themselves, and then 120 ways that we can arrange that A team with the rest of the 4 kids. Okay, so our answer is 720.